uh, all the Saturday. So to start with, I believe we have fairly 12. So, Karuba, should we start or should we wait for some more people to join?
Yeah, we can wait 2 more minutes.
Okay, okay.
Yeah.
Okay, so during the time I wait, so like, may I ask for like how many of you already have some hands-on on pandas kind of thing? So since the today's talk is about like acceleration of pandas, so it would be
Uh,
good to know that. Okay,
uh,
so Gokul, so are you saying something?
yeah, sorry, my mistake. My mic was on. Was my mistake.
Okay, okay. So anyhow, feel free to please feel free to interact. Like if you have any questions, or probably in between the talk also, if you have anything in mind that you want to ask, please feel free to turn on your mic, interrupt me, and ask. So like before the people are joining, so may I know that how many of you knows about pandas or what are the like frequency of using pandas on your regular work?
Yeah, I will go first. I use Pandas as my daily driver. I work
Okay,
as a junior data scientist, so it's my daily driver.
okay. Perfect. Anish is also saying that Anish, I'm a beginner using the Python library. So first of all, please don't say me sir. Saying Saurabh is fine. So I'd be happy to answer whatever question you may have, Anish. So Python libraries, I can assume that including pandas. Okay. Anybody else? Like, if you don't know about pandas, then probably I need to make it a little longer because I need to explain what it is, what is the method. Because I expect that if somebody knows pandas, then I can deeply talk about the internals and how to optimize, how to think smartly to optimize whatever you will be written. But if you're very new to pandas, then probably I will take that part also in consideration so that I can explain the panda side along with its internals. So I heard from Gokul, Anish. Anybody like to volunteer, say something? Okay. So okay, even if not pandas, like how many of you from this background, actually data science or data analytics background? So like Anish, Gokul said that he's working as a junior data scientist. May I have a quick like at least your position, what you're
Yeah,
doing? Even in the chat is fine. Ashok, you're saying something, please.
yeah, I am working in a data engineering role. So,
Okay, perfect, Ashok.
yeah.
Anyone else?
I'm working as data science engineer trainee.
Great. Okay. So you had a little hands-on on pandas probably. Okay, perfect.
Oh yes.
Okay.
I'm Anish and I'm a second year student in SRM University. And
Okay.
I'm learning ADS and also data science and analyst related. So we use Pandas, NumPy, Skitlearn, Matplotlib also.
Oh, perfect. So being in
Yes,
second year, you're learning this thing. So that's really good, Anish. Keep on the good
thank you.
work. So it's very good.
Yes.
Okay. And Nitish, Gopal, Roshni. Perfect. So yeah, even if you're not comfortable with the mic, you can tell me whatever you have in chat. Probably if I miss something, so I'll check and I will answer. I'm also working as data science. Senthil, thank you. Nitish, junior data scientist, thank you. Rohini knows the basic of Pandas, perfect. Okay, so I believe it's 37, 37, I mean, 10 7. So shall I start from 10 10? Then I can wait for 3 more minutes or I should start. What do you suggest, Karupaya?
Okay, you can wait 3 more
Okay, okay,
minutes. Yeah.
okay, okay. So I'll start from 10 10 then. So in these 3 minutes, anybody would like to ask anything or interact something, tell me about yourself. It's a good time to interact. Even if you're not comfortable on mic, you can ask me anything on chat or you can write anything on the chat.
Hi,
So
Saurav. Hi,
those who
Gokul here.
I go. Yeah, yes, go.
Yeah, so you said that you are a data scientist. Just wanted to know, like, what domain you are working currently, and what is the nature of the work? Are you doing predictive models or working with LLMs right now?
Okay, perfect. Thank you, Gokul. So that is something which I'll be covering in the talk, obviously. But to answer you, being a data scientist, so we have two major part. One is about the data engineering, because the data engineering is one of the primary step of creating a very good model. So data engineering, then there are stuff like predictive modeling, LLM and all, LLM and all. So our current team, basically, I'm working as a senior data science engineer. That our team here, it's basically mostly on the research side. So our focus is on reducing the max of cost of whatever it takes during the computation. So for example, those who are new might be difficult to predict, but the data grows in size. So first of all, we need to clean the data before feeding it to the AI model, right? So the cleaning part of the data takes a lot of time if your data is quite huge. So there are a lot of research areas to work on that, to improve that side. So my primary focus is to work on that side. Thereafter, when it comes to the AI model, the model is also, there is a lot of research going on, like how to optimize the model. For example, last time also somebody explained about the lang chain kind of thing, but there are a lot of fine tuning which is possible, like quantization, knowledge distillation and all. So by which we can have the similar accuracy, at the same time we can reduce the model such that it can fit to any edge engine or something. So these two are the main area. My team is called here where I'm working at NEC. So my team is actually named as Green AI. So from the name itself, you can understand that it's not only AI, it's about the AI in doing the justice with the nature. So when we do with the nature, AI, so we do a lot of emission to the CO2, and that's not good to have for the environment. So the less we can consume the computation power, the better we can do as a science at the same time for the environment. So that is my primary focus on doing different research on optimization on the entire cycle of a data science flow, starting from data collection to creating the model. So in each step, there is chances of optimization, and my work is in the entire journey.
Sure, that was great.
Thank you. Okay, so I believe it's 10:10. So if there's no questions, I can start. What do you think?
Yes, yes.
Okay,
Let's start.
Okay, so let's start. So let me share my screen. Screen share. Please confirm if you can see my screen. So the light now is my, yeah, I believe it's visible. Okay, so again, once again, so since most of you are in the very beginning, so I'll take a little time to explain about the pandas, then go into the details like why it's important to think on the optimization and what are the way by which you yourself can think of, and what are the way by which you can optimize this task even if you don't take care. Okay. So as the title suggests, our agenda is to work on the data engineering part where probably most of us are using pandas, and we'll be accelerating the same. First of all, you understand how we can optimize that, and then we'll go into how we can automate the optimization using FireDucks. And obviously, we'll talk about what is FireDucks and all. So this is basically what I answer from the Gokul. So what is the total data science flow? So probably if you are new or if you're working, so you can clearly understand this cycle. This is something which we regularly do as a data scientist or data analyst, not for analyst, probably for the scientist. Okay, so what is the steps? Step is first of all, so we collect the data, raw data from various sources. And when we obtain the data, it is quite huge in number, right? And it is very raw on the format. So some of the data having a lot of messy information, some of the data are something which is not even we are interested in. So we need to prepare the data well before we can create our AI or machine learning model. So whatever it is, it might be deep learning model, it might be predictive analysis model, but before we train a model, we need to have a sound data such that we can have a sound model. So that is the most time taking part as per the research. So if you think, check on this Anaconda site, so it is saying that starting from the data loading to cleaning and the visualization, this total EDA cycle takes around 70 to 80% of the entire cost. Because creating a model is one-time task. Once you have the model, it's fair enough. So if you have a very good model, then it's about the input to the model. And input is basically processing the data every time because the data is raw in the format. So processing the data takes a lot of time, and there is a strong need of optimization because nowadays we are mostly working on the cloud side. And if you take a lot of time, we're going to pay a lot of cloud cost. So reducing that part is very important. So that is the flow. Now, let's see, like if it is the flow and data science, like data preparation is that important. So what is the most popular tool which we use at this moment? So basically, all of you, whoever have started with this career on data science, they must have heard about Pandas. So even if you're not very familiar, but you must have heard about Pandas. And yes, it's very popular. It's here, I believe, for the last 15 plus years. And it is currently also, it is having a lot of user because it is very broad in skill. There are a lot of community who is working on it, and you can have a lot of information even when we are stuck with something. So it's very popular, and 100 million plus downloads are having on every month. And but it has some sort of drawbacks, because when it started, that time big data was not in the picture. So people usually used to work on SQL kind of thing, SQL kind of thing for the data analytics task. But Python is a very smart and easy to access language. So how about doing some analysis on Python? So that is when Pandas development started. But it was not taking care of the big data thing. So there are some challenges. The biggest challenge is that it doesn't support parallel computation. So for example, if you work in a system and that system support multiple core in the same, but it will be using single core at the time because it is not supporting parallel computation. So that is the biggest disadvantage. So the second thing is that when you're doing on the pandas, so there are a lot of choices of API for doing the same thing. And the choice of API makes a lot of difference in getting the performance. So that is again very big important thing, like which one should I pick for this particular task. So that often somebody new in this domain stuff like struggle with. So that is a challenge. And secondly, of course, since it is very slow, even if you have a lot of question in your mind to like analyze, okay, let me try this, let me try that, because of its slow nature, if you have a larger data, you might not be able to do it very quickly. So that will affect your efficiency. And of course, because of its long running execution, it will take a larger cloud cost. If you're using AWS kind of thing, it will attribute a lot of CO2 emission in the environment. So that will not be a very good thing for the environment, right? So these are the drawbacks, some of which, of course, you must be knowing. But the most important is that even if there are drawbacks, you can yourself write a better pandas code if you take care of a few things. And that is the agenda. Like we'll understand what are the ways that we should take care to write a better pandas code. And is there any automation possibility? So if that is available, what is that? Okay, so before jumping to that, since most of you are new, so let me have a quick kind of ice breaking to understand. I am just taking 5 simple queries to know that you are quite familiar or somewhat familiar with the upcoming slide, because I'll be using some of the methods in my slides. So before jumping to the methods directly, let's have a quick quiz. So anybody from you, like if you like to answer this particular question. So what I want to do is, this is my data. I want to obtain this. So I want to get the top 2 rows based on the A column. So if you check the A column, there is 8 is the topmost, and this row, 4th row, is the second top. So I want to do this. So in order to do that, can anybody of you saying like what is the method which I might be using to get that information? Any quick, like anybody, like, fine. Even if you don't know, you can guess. And now a different I will explain. So shall I? Okay.
I think it's fourth. To get the top two, right?
Okay, perfect, Gopal. So 4th is the answer. Thank you. So basically, there is no, first of all, there is no short method. The name of the method is short values. So that is the same thing, like short values means, because pandas has 2 things, right? It has an index column followed by the data column, value column. So that is why it has 2 methods: short index for sorting the index column, short value for the sorting the value column. And since I want to do the topmost on the A, so I need to do a descending sort. That is why there is a parametrical ascending which I made false. and head 2 means top 2. So that is a method. So please remember, in order to sort a pandas data frame based on a column, we'll be using sort values, then provide the target column by which I want to sort. Then if I want to do ascending sort or descending sort, and then you can pick head 2, 3, 4, the top 2 and 3. So that's it. Okay, perfect. So the next question is, I want to do merge of, sorry. Uh, so I want to do join of these two tables, df1 and df2. Okay. So based on the common column x, so you can see there is a x column which is common in between these two. And of course, when we'll do inner join, that will be the result. Any one of you can volunteer like what, there might be more than one option which is correct in this case. So how I can join these two tables to get the third table? I mean the resultant table.
Yeah,
Gopal, once again.
1 and 3 might work because 4 default value will be, I think, left, how equal to left. So 1 and 3 might work.
So actually, it's 1, 3, and 4. So to you, the default for how, first of all, thank you for guessing the default one. Yes, the how parameter is default, but the default is inner, not left. So since the default is inner, so this will also do the inner join. So for others who doesn't know about it, so basically, definitely I can guess that you know what is joining. So joining means something which you study in our database also. So there are two tables, there is a common key column. Based on the column, we will be joining two tables, right? In Pandas, there are basically ways of a method, data frame method. The name of the data method is merge, by which you can pick one data frame, dot merge another data frame. Okay. Then on is a parameter by which you can see on basis of which column you want to join. And how is a parameter? As you can understand that there are different way of joining, inner join, left join, outer join, something. So how is a parameter by which you can specify? But the default how is inner. So 3 and 4 are mostly same. There is another way of doing it also as a global method, not as a member method, but also the module method, which is pandas pd.merge. For that, you need to specify both the df1 and df2. So this is again one of the basic essential, like how we can join two tables. Okay, so the third question, basically this time what I want to do, I have to do filter. Okay, so this is my input data and I want to filter rows where B is having values greater than 20. Anyone from you? Again, there might be more than one option, which is correct.
Yeah, 2 and 3 is correct, I know, but the 1 I haven't used, so I'm not sure. So 2 and 3 is my guess.
Perfect. Thank you, Vipul. So of course, 2 and 3 are correct and 1 is also correct. So the answer is all of the above. So let me explain why there are 3 and what is that. So basically, this is the simplest approach. 2 is the simplest approach that we often do. What it says, df is my data frame, total data, and dfb is the target column on which I want to do filter. So I will write on the column of B from DF. So DF, okay, let me just turn on the laser so that, okay. So DFB, so this is the column and this is the condition. So from B column, which whatever values are greater than 20, I will create some true false thing. For example, if some column is having greater than 20, it will be true, otherwise it will be false. So some true false mask is created in Pandas. And after that, whatever has been true, that will be selected. Whatever has been false, that will be discarded. So that is a simple filter operation. And most of us are perform two. But if we want to do method chaining, for example, 2 doesn't allow you to write a method chaining, which is very important when you do think of optimization. But 2 doesn't allow you. For that, you can choose either the dot pipe operation or dot query operation. Query is a very simple way of writing. It is a like there is no syntax. You can just specify the query as it is, something similar to SQL also. So you can say, okay, I want to perform filter where B is greater than 20. So simplest one. And one is using pipe. By piping means whatever is your input, you add a pipe on that. And this T is the current state of your input. That means current state of your data frame. And on that data frame, you want to do filtration. So all these three are correct. Okay. So now just to answer like why 2 cannot be used as a method chain, but 1 and 3 can be. Because, for example, the last example, we do merge, right? So we'll do merge of df1 and df2. But when we'll do merge, there will be new table will be created. But what I want the filter from that new table, not on the input df1 or df2. So on that new table, you cannot write something dfb because the new table is not stored somewhere. So you cannot write something like this. So whenever you want to use this syntax, you have to store the information somewhere, then you can use that. So that is somewhat disadvantage of doing this particular syntax. But if we use query, you can always use the current state of data frame. So after the merge, whatever the current state of new join table, on that table, you can perform the query operation. So that is very good because it will allow you to write the methods in chain. Another thing is pipe also. So when you will do df1 dot df2, merge df2, the current state of join table can be readily used as a pipe to filter. So these two are usually recommended because of chain operation. Okay, and why chain is important? Because if you don't perform chain, what will happen? For example, what is the advantage of 2 and 3, 1 and 3 from 2 is like here, since the result is stored somewhere, so as long as the reference count of df is available, it will not be available to be freed from the memory. So it is not ready for the garbage collected. But if you write as a method chain, what will happen? Whenever your merge is done, the reference count of and queries performed, at that time the reference will be lost, right? So it is ready for the garbage collected, and you can write as a better optimized way as far as memory is concerned. So it's very important to write in the chain operation such that whatever is temporary and performed in the earlier stage, that can be collected by the garbage whenever there is a need for the newer memory. So it's very important from that sense, but you can choose whatever you like. So there is flexibility from the performance point of view, all three fine. But 1 and 3 is good when you want to write a chain of operation, not only single operation, but chain of operation. So of course, I'll be explaining this in more details in upcoming slides. Okay, so now the fourth one, it's very easy, I believe. So anybody can answer. So what I want to do, I want to select 3 columns on this from this entire A, B, C, D, E, but I want only A, D, and E. What are the ways?
1 and 2 is correct, I guess.
1 and 2.
Gatesh is also saying 1 and 2. Okay. So actually, once again, so it's all of the above. 1 and 2 definitely, because 1 will directly saying you that I want to perform A, D, and E. 2 is a new way of doing where not only columns, but also you can specify whatever row you want to do. So here, when I write colon, that I mean to say that all rows and A, D, and E column. So this is way of writing when you want to select row along with column. But when you need all rows, you can just specify colon as for the row indicator. And what is ilog? The I stands for the index of that column. So here, if you assign some index, A is the 0th column, B is the 1th column, C is the 2th column, D is the 3rd, and E is the 4th, right? So by which, since I'm using ilog, that means not by the name, but by the position. So here, A, D, and E, that means 0th, 3rd, and 4th, by which also I can get the projection of the column. So these are the 3 ways. Option is that how can I add a new column? So this is my data A, B, C, D, E. I want to append a new column if by doubling the value in B column. Anyone? Venkatesh, Gopal, anybody else?
1 and 2
1
maybe.
is correct.
1 correct.
Sorry, one by one, please. So 1 is correct. Okay,
1.
perfect. Okay, what else?
2 maybe.
2 maybe. Okay, anything else? Something in chat? 1 and 2, same thing. Okay, 1 and 2 are correct, definitely. There is one more option. Out of 3 and 4, anybody can guess which one can also be used?
4 because I haven't seen with columns anywhere. So 4 maybe.
Yes, yes. So the answer is 1, 3, and 4. So 1, 2, and 4. So 1 is very simple. Just extract the column B, multiply 2, and assign it as a new column F. So it's simple. Two is a method, new way of writing as a method chain. Once again, it can allow you to write as a method chain. By saying assign, you can assign a new name, for example, if, and how if to be populated by multiplying b with 2. Div insert, by saying the insert, you need to specify at what position. That is the challenge, at what position. So I want to append at the end. So this is the 5th position I want to insert. What should be the name of my new column? The name of column is f. And how should I compute the value of f? That is multiply 2 with p. So these 3 are the right options. So, okay, fine enough. So that is a quite ice breaking kind of thing with the pandas. Now let's jump to the actual task of today's purpose, like smart way of writing code along with the auto optimization. So from this slide, I want all of you to pay very good attention. And if something is not clear, stop me at that very moment and ask me whatever question you may have. If you're not comfortable on a mic, please ask me on chat also. It's fine. Okay, so now it's what I want to do in the sample query. From the query, since you already have heard that short is for doing shorting, query is for doing filtering. And this way we can select the column which I am interested in, and head is picking the top 2 or something. Okay, so you can understand what I'm trying to do is, if I have a data frame, I want to sort the data on A column, then I want to perform the filter on B column where value of B is greater than 1. Then after that, I want to select only E column from the result. And after that, I want to pick the top 2 of the E column. So that is thing. Okay. Now to understand it, let's think instead of number, let's use some color code. So let's see, this is my data. And as per the sorting order, let's see that yellow should come first, then red, then green, and then blue. Okay. And for B, let's consider 1 for the darker shade and 2 for the lighter shade. Then we can understand how it works. So, okay, so when we'll be performing, this is my data A, B, C, D, E, having some lighter shade color and darker shade color. And darker means B1, lighter means B2. Okay, so when I'll be doing sorting, what will happen? Sorting means the result will be sorted by some specific values. Here I'm using color code for the sake of understanding. So what will happen? The yellow shade will come first, followed by red, followed by green, and then the blue one. So that is my sorting thing, which will happen. Perfect. After I do sorting, I want to filter where B is greater than 1. So B is greater than 1 means I want to filter the lighter shade from this sorted result. So the lighter shades will be filtered out. The lighter yellow, lighter red, lighter green, and lighter blue will be filtered out. Once the filter is there, I only need E column from my result. What is the result? This one. So I need E column. So I will perform a projection and I will get my E column. Once I get my E column, I want to pick the top 2 from the E. So top 2 means the yellow one and the red one will be the answer. So if you write something like this in Pandas, you may have different problem to solve, but something if you want to do, internally some of this flow will happen. Data sorted, filtered, projected, and the top 2. Now, if you carefully note this, there is a lot of performance problem issue with this code. So that is, I will be explaining the right hand side with the optimized query. But before that, let's see in this entire query, I'm only interested in A column, B column, and E column for my sort, filter, and projection. But since I'm considering the entire data, so where the data has C and D column also, probably it may have other columns also. Those are not required in any of my result because I'm not interested to get any information from C and D in my final result. But since I haven't performed anything for that, those will be used. That will consume the memory during the execution. Execution time will also be taken, but that will not be used. So it will be useless computation and useless consumption of memory. So that is a very important point to take care from this particular way of writing. Now, probably how we can optimize this code, one of the way is this. Now let's understand what it's trying to do with the same picture once again. So this time it's very important for me to understand what my core problem is. My core thing is that I want the shortage, I want the top 2 from this data based on E column, from the E column, right? So my primary objective is to sort the data and select the top two of the E column after the sorting. But since I want to sort the data, it's very important to reduce the scope of the sorting. Instead of sorting the entire data, because entire data means a lot of row and lot of columns in your data. Whenever you think, if you think for the bigger data in picture, there is a lot of columns and a lot of row. But if I try to do sort on entire data, it is taking a lot of execution time. So it's very important to understand what is my area of interest. My area of interest for this particular query is A, B, and E column. So first of all, let's only select that part, reduce the scope of the data from that part which I'm interested in. So I'm interested in A, B, and E. I will project only A column, B column, and E column, and I will reduce it horizontally. That is the first step. Second step is before jumping to sort, I can reduce the data further by filter out it before sorting. So if I do the filtration, again, my further scope of the data is reduced. First, reduction on the column label, then reduction of the row label. If we do so, this is the actual data on which I can perform my sorting, because all of the part which I have eliminated, that was not required in the entire query. So reduce on column, reduce on row, then jump to the actual operation. Now my data is ready for further operation. What I'll do, I'll perform sorting. So again, sorting is something like yellow, red, green, and blue. After the sorting, I'll select the E column. After the E, I'll perform the top two of the E. So if I can think of this way, then you can save a lot of computation time, with proof I'll be showing in upcoming slide. But that is the rule of thumb, that before doing any operation, any computational extensive operation like joining, sorting, grouping, please define the scope of your input data well, such that you can reduce it on the column and row level, and you can save a lot of computation time and memory consumption when your data grows in larger. Okay, so this is an hands-on. So with this hands-on, we'll understand how this kind of optimization helps. It might be a little difficult to understand, so I will go a little slow here. And if you have any question or if you don't understand something, please stop me. Okay. So what I try to do is I am taking a query from a very popular benchmark called TPC's benchmark. This is a benchmark for doing a lot of transactional data analysis. And there are, I believe, 7 to 8 tables in the data. This is the common ER diagram showing what are the number of columns in each of this table, what is the size of this table, like how many number of rows are there in each table, and what is the relationship between the tables. That means which column is the key to and which column is the foreign key, kind of thing. This is there. So there is a query in this query 3. It is trying to get top 10 unshipped order with the highest value. And that was the SQL implementation of this query. So let's consider the SQL implementation is given to you, and you have been asked to write the equivalent pandas one. Okay, so that is your task. I have the SQL. Now I want to write it in a pandas way. So basically, first, let's not think much. Let's just try to think how can I pick the SQL elements and convert it to Pandas elements or Python elements. Okay, then we'll think of optimization, the optimization way that we have discussed in the previous slide. So first of all, what if we check on the SQL, probably some of you doesn't know about SQL, so for them I'll go slow. So here is a from part. So from part means I want to perform my operation on these 3 tables: customer table, order table, and line item table. Customer table, line item table, and order table. So you can forget rest of the table. So I am for this particular query, I'm interested in doing operation on this 3 table. Okay. This table, I need to operate on this 3 table. So since I want to operate on this 3 table, what I need to do is I need to join this 3 table, because some of the information here, some of the information here, and some of the information here. If I join them, I'll have all the information in same table. Then I can further do whatever I'm interested in. So the SQL also suggests from this, and how to join this. There is a condition like customer key from the customer table should be matched with customer key from the order table. So key from the customer table should be matched with customer key from the order table. That is the condition of joining customer with orders. And what is the way of joining with line item? Order key from the line item should be matched with order key of order table. Order key of line item should be matched with order key of order. So this is the primary condition by which I can join these 3 tables. Okay. So let's do that. I have my customer table. Let's perform merge. The way of merging I explained in some slide ago. Those who knew, fair enough. So customer dot merge with order table. what is the column for the key to order? Customer key from customer table and customer key from the order table. So I'll join these two tables. So joining is done. Customer and order is joined to create a new table. Then I need to join that table with line item also. So again, one more merge I need to do, one more joining operation I need to do, this time with the line item. And line item, what is the key? Order key from the order key and order key from the line item. So if I perform this step, so I will have a new table having all the information for customer, from line item, from orders. Now, what the SQL demands you? The SQL demands you to filter out where clause means condition. That means I want to now filter something which I don't need. So what is my filtration? That market segment should be building. So once again, it is saying that market segment should be building. So let's filter. In this data at this current stage, I'm piping and I'm filtering wherever the market segment is building. That filtration done. Now next is what? Order date should be lesser than this date. So order date should be less than this date. Again, one more filter. Third filter, shipping date should be greater than that date. Shipping date should be greater than that date. So this way, I have joined these three tables and filtered out whatever I don't need. Now what I want to do, I want to perform some kind of new operation, that extended price multiply with discount and create a revenue column. So getting a new column using the assign method, I can do the same thing, extended price multiply with this to get a new column, the revenue column. Okay. So once that is done, I want to create a group by operation. Group by should be performed on these three column. In Pandas also I can do the same way, dot group by on three column. And after group by, I want to get what? I want to get the highest value, right? So I want to perform after grouping, I want to perform the summation on the revenue such that I can get the top two from based on the revenue. So here is also it was. So I will perform the aggregate sum on the revenue column and only get whatever column I am interested, because it is saying that you need to select order key, revenue, order date, and priority. So I'll be selecting these four columns from my result. And finally, the result should be sorted by the revenue in descending order and order date in ascending order. So should be sorted by revenue in descending order, order date in ascending order. And finally, I need to pick the top 10. So I'll be taking top 10. So this way, from this SQL statement, I can convert to my Pandas one. Perfect. So that is the first implementation from this SQL to Pandas, but it has a lot of challenge. As you can see, that customer table is quite huge. It is having almost around 1 million, right? 1 million sample. Here it is having 6 million data. Here it is having around 1.5 million data. So quite huge. Not only row, but also it has 8 columns, it has 16 columns, and it has around 9 columns. So there are many row and many column. So if I work on the entire data, I'm going to pay a lot of cost. So from this, so since I have my first Pandas version, now let's optimize that. So how I can optimize? Follow the principle which I explained. The principle is, first define the scope of the input data. Instead of operating on the entire data, first reduce the scope. So from the customer table, if we carefully observe, I only need customer key and the market segment. Although it has 8 columns, but I only interest in 2 columns for this entire query. So I will first select only those 2 columns to reduce it in horizontally. Then what was the condition? Condition was to filter this table on wherever segment is building. So this time I will reduce in the row level. Okay. So first column, 2 column, then only those row where segment is building. So this way I can first reduce my scope of customer table. Same applies for orders also. Although there are 9 columns, but in this entire query, I only need customer key, order date, and shipping priority. Select those columns. Filter operation, yes, I need only those row where the order date is less than this date. So this time I'll be filtering. The same thing in line item, which is a very big table having 6 million rows and 16 columns. But in this query, I only need 4 columns: order key, shipping date, extended price, and discount. Select those columns, then filter on the shipping date, because I want to get those row where shipping days is after this date. So I'll perform the filter. This way I perform projection, that means selection of column, and filter, removing of row, and reduce the scope of my customer table, order table, and line item table. After that, if you perform the same query, that means merge, but this time instead of merging the entire table, I merge the reduced table, filtered customer with filtered order, after with filtered line item, and perform the same operation and execute in Pandas. So this table was this code was taking around 68 to 70 seconds. You can consider 70 seconds to 10 seconds, around 6 and 5 to 7 times performance you can get by yourself by writing this way. So if you can carefully think of your scope of the data during the writing of any analytical query. So basically, whenever we do ED operation, we create a lot of new feature, and lot of new feature needs to combine different table, perform sorting, perform group by aggregation. That time, if we can carefully think of that what should be my ideal way of execution, you can definitely reduce a lot of time, even if you're using Pandas. Okay, so execution order is very, very important in order to optimizing the data flow in a large scale operations. So now let's think how we can actually automate it. So for example, even if I am not that skilled at optimization, I write this piece of code. Can I have something which will rewrite this for me? Okay. So is there any way for that? Okay. So that is the idea for FireDucks. So let's explore those idea and slowly go into the FireDucks from the slides and see another thing also. The first idea is, can I optimize this thing? So if I have this side of code, so this is, for example, if I have this code, can I get this code automatically by using my something? So of course we can. So how we can do so? Using a compiler driven technology. Okay. So there is a very popular framework called LLVM. So probably some of you have heard about it. So LLVM is a framework which allow you to do kind of create, instead of execution, it allow you to create some kind of intermediate instruction like the compiler does. And from the intermediate representation, you yourself can perform a lot of optimization. And from that optimization, you can generate the optimized query. So that is something is a scope, and I'll explain. So for example, if I have this particular code, I can use my LLVM to generate some instruction for each of this method. So if I feed it to LLVM, I can get something like this. So it will generate an instruction instead of performing the sort. It will generate an instruction that I want to do sort on some data and on a column of that data. Then the result will be, for example, V2. Then I want to do filter. So it will generate an instruction for filter on V2 based on this query. I want to perform the projection on E. It will create an instruction project on V3 based on E column. Finally, I want to slice top 2. So it will create an instruction slice on V4 and having top 2. So this is simple some instruction. So now if I have this instruction, I can have a lot of way in my hand, because when I have the code, it is difficult to think of, okay, how can I perform query faster? Automatically, definitely. By manually, we can definitely do, but automatically it's difficult. But from the code, if we can have this kind of intermediate representation, we can now use some kind of optimization by which we can see, okay, what is your result? Result is V5. What is V5 is doing? Slicing. V4. Okay, let's now see what V4 is doing. V4 is projecting E. That means from this step, you can understand that I'm only interested in A to be projected. Now go back to the input of this, which is V3. It is doing filter. Okay, that means I also need to do filter. Go back to previous step, V2. I want to do sort. So from this step, it is very clear. Sorting is performed first. Now I can provide this instruction to some engine which I can develop, and that engine will perform the reordering for me. What will be the reordering? First, select the column which is needed. That means A, B, and E. Then perform the filter on the B column where B is greater than 1. After that, do sort. Then do project E and then slice on top 2. And if we convert this back to the pandas once again, sorry. then you will have the optimized query. So project ABE, that means pandas ABE, filter b greater than 1, query short, get E, project E, top 2, slice 2. So in this way, if we can convert our code to an intermediate representation using the LLVM, and then we can have a lot of scope to optimize it. The optimized instruction can be easily converted to pandas, converted back to pandas. So that is the first principle that we have used in the new library, which I'm going to introduce. The name is FireDucks. So it does the same thing. Whenever you give a pandas code to it break down the pandas code to some sort of intermediate representation. Then the internal compiler inspect all the code flow and create a reordering of the code flow such that you can have a better pandas version. And then when the better pandas version executed, you will get much faster performance. That is one thing of auto optimization. Now, second thing is that pandas is slow because it is not multi-threaded. So instead of sending back to pandas, I want to have my library which I will use multi-threaded, because pandas does, even if I send back to pandas, I will have optimization because my data scope is reduced, but pandas doesn't allow you to do multi-processing or multi-threading. So even if you write this one, this will be slower when compared to other platforms. So this time I want to do, okay, so I solved my query optimization. Now, instead of sending it back to pandas, I will create a new library, new backend library. That library might be written in Python, might be written in C++, might be written in any other language, for example, Rust, Lua, whatever language it is. But that library, I will parallelize all the computation. For example, filter can be simply parallelized, sorting can be parallelized, and all of the algorithm I will make parallelized, and instead I will be using that. If I follow this way, so compiler will take care of the data flow related optimization. And once the flow is optimized, this will take care of the multi-threading, memory related thing. So overall, you will get much faster benefit if you have this kind of mechanism. And that is what we have implemented in FireDucks. That is a library that is developed in our laboratory. It is currently freely available for you to be installed in any of your Linux platform using pip command. So what is the principle behind is that, so it will accept your pandas program, break the program into some specialized IR that I have explained. Those IR will be compiled using the MLIR technology, and it will create an optimized IR. From that optimized IR, I can convert back to my multi-threaded CPI, multi-threaded C++ API. So here data flow will be optimized, and here multi-threaded part will be optimized. So overall, whatever you will write, that will be optimized because of these two things. Okay, so that is something. So once again, let me introduce FireDucks. So FireDucks is nothing new for you. So if you know pandas, you can use as it is, because you don't need to make any code changes. You don't need to learn anything new, in terms of API. Not only any existing pandas program, if you're using any library which use pandas, for example, Cburn, for example, Matplotlib, why data profiling, something that internally using pandas, that can also be executed with FireDucks without any problem. And about the speed, because it has multi-threaded, so all your operation will be faster because it can use all the available core in your system, and it perform just-in-time optimization using the compiler technology that I have explained. So whatever way you have written, even if you are written the poorest way, compiler will detect and it will reorder execution. If you're smart enough and write the reordered one, then good for you. But if as a data scientist, it is not, it often we don't write the optimize because we're not the expert programmer. So we often don't write the expert way. That time, definitely we can just, okay, FireDucks, please do the optimization using the compiler. So that is something. So it is lazy. Instead of executing everything, it create instruction and generate them. Whenever there is a need for the execution, it compiles the instruction and generate a newer optimized code. Then it will be executed in a multi-threaded environment to get the faster result. And definitely using it, you can obtain faster data analysis. If you're using AWS like of thing, cloud kind of thing, you can obtain this kind of 10 times, 20 times speed up. So you will reduce your cloud cost to a greater extent. And of course, that will be an economical solution. But the most important, you don't need to learn anything new. So if you know pandas, that's fair enough. Just install FireDucks and you can use it. That is the principle. Okay. Now regarding the usage, here are basically two way of using it. So one is, instead of import pandas, once FireDucks is installed, you can use import FireDucks.pandas. That's it. Then all your code, however it is written, it can be accelerated by the compiler, which it has, and of course by the kernel with the multi-threading. But if you don't want to modify this program, especially for example, you have a program which is using pandas, but not only your program, but some internal module, for example, module A and B, and all the module internally using pandas. So it is difficult to replace all the import pandas using import FireDucks pandas. That time, just before executing your script, provide -m option. If you provide this, all import pandas will be automatically replaced by import FireDucks pandas and will get the speed up without any code modification. If you're using some notebook platform, for example, Jupyter, for example, Google Colab, then you can add this extension on top of any import. So if you do so, these pandas will actually become FireDucks pandas, and whatever part is written inside your notebook, that will be accelerated. Okay. So here I have some like benchmark. So this benchmark is saying that basically it is called DB benchmark, where there is a lot of group by and join operation and mini library. Of course, you see that Pandas is the slowest one, and there are many other version of Pandas, for example, Polars, DuckDB, data tables. There are many other library, which is the first version of Pandas, which have been developed over time. But when we compared all the query in this benchmark, you can see that FireDucks was on top of them. So it can offer you that first performance just by replacing the statement or by using the -m FireDucks pandas option. There is the TPCH. I explained a query 3, but actually in total there are 22 query. When you measure the performance, the FireDucks was on average, it was 18 times faster, where Polars and other library, which is the faster version of Pandas, they're also faster, but FireDucks on top of all the query. There is another benchmark called TPCX. That benchmark offer you 30 different query. In each of this query, you do the actual way as data scientists perform. For example, load data, create a lot of feature and perform machine learning model, whatever deep learning model. So that stuff also, just by importing pandas, we can accelerate in all of the query. They can be accelerated without much changes. So now for the resources, if you want to know about more on this, so basically you can we have a website. So basically you can go to the website for the details, and there is a lot of articles which have been published. You can check into the articles. You can follow the Twitter GitHub page for the regular updates, and definitely you have a Slack channel for example, if you start using FireDucks and have some query, you want to know some optimization, how it is being done, you can definitely perform some QA and we'll be happy to assist you. So here is a Google Colab. This Google Colab is showing you, so if you want to have a test drive, so basically what you can do is, I'll be sharing definitely this slide with you. You can go here, and here I have created some basic query. So basically, so I have created some query for you to have a hands-on. So it's do word, it perform word, it first load the data. So it use some parking violation data. It loads the data. Data loading is being done. After data is being loaded, it tried to do some kind of query. For example, which city in the US state is having a lot of parking violation? So this is the query for that. Okay, I will select perform value count to know the top two. So top one, and then sorting and this kind of thing. So these are the query which is once executed in Pandas, and then using the extension which I suggested you, like if you're using Notebook, you can simply add this extension. If you do so, all your Pandas will be optimized. And this Colab support only 2 core, because by default Colab doesn't support a mini core. So 2 cores were there. So when I have executed so Pandas was taking 15 seconds at the overall query. But since it has 2 cores, and it is multi-threaded and optimized, so it was around 7 and 5 seconds it was taking. But if you have a multi-core system available, you can download this notebook and try it on your own to get faster. When I tried on my side, I could actually get 25 times speed up, because it was like 0.5, because I have 48 core system. So anyhow, so that is something, but the idea is that you can understand or you can just explore whatever pandas you know. You can write your code it's very good that you understand what is happening internally and you yourself write a beta code. But if you are not confident enough, you can write pandas and then assign -m FireDucks.pandas to make it accelerated using FireDucks. And then you can definitely enjoy the green computing. So yeah, so that is the end of this talk. But of course, if you have any questions in mind, I'll be happy to answer. So feel free to ask me whatever question you may have.
Can we control the parallelism? Whether we can give parallel 4-8, something like that.
Ashok, I didn't get you. So can you confirm the parallelization stuff? So what do you mean by that?
You said like FireDucks can do multi-threading, right?
Right.
Yeah, it's a default multi-threading, or can we control whether it will take a 4-core, 8-core or something?
Okay. By default, it will use all the available code. But if you want to configure it, for example, if you have 10 core system and you only want to use 4 core or something, you can use the default, like as you must be knowing that OMP num threads is an environment variable. So, sorry, OMP threads. So you can use this variable to specify,
So this is environment variable, right? We have to specify
this is
that there.
right. Before
Okay.
using before importing FireDucks, if you set this environment variable, so it will use those many cores. But ideally, if you have many cores and other cores are not used for other purpose, you don't need to specify. By default, it will be using all the available cores. But if you're using, first set the environment variable, then for example, Python -m FireDucks.pandas and your program. So your program this time will be using only 4 cores. But if you have already executed in Python program, so in Python program also, you know that how it can be done. So you can import OS and you can set os.environment and you can specify, okay, I want to set this environment variable and the value should be 4. So this way also Python programmatically you can do, or before executing Python script, you can set the environment variable and use it. Both way fine. This is the usual way of like controlling any C++ related, like using OMP. That is a standard way usually. Specify OMP num threads and you can control the number of cores if you don't want to use all your cores. But if you don't do it, it will be by default all cores.
Yeah, thanks, sir.
Yeah. So I also have a doubt, like, does FireDuck do any API calling, or all the processes done locally?
Locally. So API calling, what do you mean by that? Like, does it
Like,
connect with
will
some
it?
server?
Yeah. Does it
No.
connect with some server, or
No,
all
no,
the
no.
things done locally?
Everything is locally. Everything is local. So you don't need any internet connection when you'll be doing it. Just install FireDucks. That is the only thing you need an internet connection with. So once FireDucks is installed, it will be completely in your local system. So if you have a very good system, for example, at least 8 core, so you'll see quite significant speed up because everything will be used. And if you want to use AWS or something, then that is definitely AWS can be used for using AWS needs connection. But when you'll be using FireDucks, because this entire flow, what I have explained it, there is no connection making, right? So just input will be there. The FireDuck itself has the compiler. It will create instruction. Those instruction will be optimized. After the optimization, it will be using the library. Everything happen. So this part, it comes with as a bundle of the library. So you don't need to, for example, of course, why don't you do it? Because we don't want to break any security, right? Because your data is very confidential. So it's not good to share the data to some server and then get the result from there. That is why everything is local. So if your local system is not having not that good specification, you can definitely switch to some AWS in a safe AWS environment. But as a library, it performs everything locally. Just install it and then stop the internet connection and keep using it. So there is no safety concern with this.
Yeah, I think that's definitely good, because that data security is really important.
Yes. Thanks, Gokul and Ashok. So anybody else having any questions? Probably in the concept part or wherever. So actually this is very small because I had only 1 hour. So I just could explain this execution reordering, the impact of execution reordering, because it's very important. Apart from that also, FireDucks can do a lot of other things. For example, you are from the machine learning background, so you know that there is parameter tuning, which is hyperparameter tuning, which is possible for some machine learning. The same thing is also possible for pandas. So because pandas, all the methods, for example, joining, sorting, or grouping by, they have many default parameters, and all the default values are not all the time right for your use case. So if you change the default value, you can get a for much faster performance. That is again a job of the compiler. It instruct your code and understand what you want to do. If we see that in your code, some of the parameter is not like default parameter is not good fit for you, it will change the default parameter by which. So that way also you'll get performance. And there are other ways also. So probably if like this is for the 1 hour time frame, I just make this, but if you're interested, probably I can have another way where I'll be discussing some details on that, some different part. For example, why chaining of method is important from the memory computation point of view, how FireDucks do thing from the memory point of view, and also like this way, like pandas tuning, tuning of the apply statement, the other parts. So by the way, like I'm not sure whether I should say it here or not, but probably since you are from which region, mostly Hyderabad or Bangalore side. So there is an event in PyCon India, right? Which is happening in the September. So if anybody from you are planning to join there, I'll be there. So definitely we can have like interactive one-to-one discussion if you are interested to know more about it or more about optimization and other area of the optimization. So if anybody of you planning to go there, let's meet because I'll be there.
When and where, Saurav? Could you share any event information?
Look, when is it? So your question, it is PyCon India. So it is a conference which is happening in Bangalore. But if you don't have, if you haven't registered for it yet, so probably the tickets have all been sold. So probably may not be able to register because all the tickets have been sold. But we have sold all the tickets, yeah. But if you have registered, then probably I'll be there to have a discussion. So it is going to have a lot of discussion on this type, because if you check the schedule, actually, so in the schedule you can find a lot of interesting talk, this kind of thing. But if you haven't registered, probably this time you may not be able to join. So actually I'm conducting a workshop there, and this is my workshop. So where I'll be having a 3 hours workshop and discussing a lot of different area of optimization and other stuff also. So if anybody of you coming, so definitely we can meet. And if you're participating in workshop, then definitely we can understand more. Even if you're not joining this workshop and find it interesting, we can have this kind of session also on this meetup, and that is fine again. So basically it's about sharing of knowledge and like improving each and other efficiency. So if you join, then it will be good, because I'm from Tokyo, so it's we hardly be able to meet in person. But this kind of events happen, so we can interact. So if you're coming, then definitely we can have a interaction. But anyhow, if you are not also planning to come, so you can definitely reach me on the Slack channel or probably in another meetup. If you're interested, we can conduct other optimization and we can discuss more. But the key thing is that if you're using pandas, so first of all, think wisely. And if that is sometimes sound challenging, probably you can try FireDucks and assign it to optimize it, because you don't need to rewrite anything. Just write a pandas code and use as a plugin and optimize it. Okay.
Thank you, Saurav, for your insightful session on FireDucks. It's powerful optimization for Pandas queries. We are grateful for your expertise, and thanks to everyone for participating. Let's keep moment going, and also we'll see in the next events. Thanks, everyone.
Yeah, thanks,
Thank
Karupya.
you.
Thank you. Thank you.
Yeah, thank you for organizing this. This was really useful. Yeah.
Great.
Yes,
Thank you.
thank you, Karupa, once again. Like, Thank you for hosting me and allowing me to present this work. And thanks Ashok Gakul especially for interacting so much with me. It was my
Yeah.
pleasure.
So yeah, so interactive in this session. Yeah, really. Thank you
Yeah,
everyone.
thanks. We'll meet in
Thank
future
you.
event.
Sure. Take care. Bye-bye.